I'm alone, I'm a broken home. I gave you all the bricks that I own and know. I'm letting go, I'm breaking these walls down, breaking these walls down. If you want adventure, then fly to home. But if you wanna travel, then go alone. Yeah, what's the point in us if I never know? Yeah, if you're gonna leave, I'ma let you go. I'm tired of the pain. Go away. I'm tired of yesterday. I fell where my demons dwell. My own little nightmare, I call it hell. Oh well, it's time to get back up, climbing and climbing. I'm done with this ride, is what I tell myself, so I could feel something else. Yeah, I guess I had my bad days, but it doesn't mean I lost myself. Darling, where were you when my heart was on the ground? I thought time would prove that you would stick around. I guess time stands still, a king without his crown. Now I'm breaking, you're faking, girl. You never made a sound. I'm tired of the pain. Go away. I'm tired of yesterday.
Hello everyone. Hello and welcome to another edition of the Azure Cloud Security Meetup group. So thanks to everyone that's taking the time to join us. So we're glad to have you all here. And we do have a very special session for you today. So, but before I go into the session, if you're yet to join the Meetup group, please make sure you use the link that you have on the screen, which I'll also put in the chat window. Use that link to join the Meetup group, and you'll be kept up to date with events that we're going to be having. So if you go ahead and like and subscribe to the YouTube channel, that'll be very good, because again, you can get notification if we put out any new videos, any new recording. So we do have speakers like Karl that join us regularly to speak on Azure security. So enough about that. So we do have a special session today, and we have Karl back. So Karl and myself, for those of you that may not know, so we did co-write a book together, which is Penetration Testing Azure for Ethical Hackers. So I had an amazing experience writing this book with Karl, and I'm looking forward to edition 2 of this book. There's a lot of things that's come out since then. A lot of new information on Azure security that we'll be glad to include in the other edition. But you can use the URL on the screen to also order the book. But enough about that. Let me go ahead and bring Karl in. Hello, Karl. How are you doing?
Hello. I'm doing well. Yeah. How about yourself?
Yeah, doing good. It's been a long time, and I'm sure like it's been very busy for you, also similar to like what's been going on at this end.
Yeah. We had the end of the year, which Q4 is always really busy for us, and
Nice.
busy start of the year, but really good to see you and catch up with you.
Yeah, and Microsoft are not making it easy, right? So we do have all kinds of different, vulnerabilities that's been detected since. I mean, I think it's like probably been since the book came out. Probably there's been like about 5 in a row of just like major vulnerabilities, including the ones that you yourself came up with. So, by the way, for those that don't know, Karl is on the leaderboard of the Microsoft Security Research leaderboard. So, congratulations on that, Karl. Great job.
Thanks.
Yeah, awesome. So Karl will be speaking to us today on exploiting Azure Automation Account, and I'm really looking forward to this because, again, Karl is someone that has a depth of knowledge when it comes to the area of Azure security. He has been putting out consistent work in this area. For those of you that may not know, one of the most popular tools when it comes to exploiting Azure is Microburst, and that tool was written by Karl. So do check out that tool. Again, I'll put the link in the chat window for the GitHub repo for you to check out the tool. So anyways, I'll hand over to Karl now for a session on exploiting Azure Automation Account. If you have any questions, do put the questions in the chat window, and we're going to ask them to Karl at the end. So over to you, Karl.
All right. Sounds good. And looks like we got the slides up. Perfect. All right. So this is exploiting Azure automation accounts. Today, we're going to talk about automation accounts and all of the different things that we can kind of do within the automation account infrastructure. It's actually quite complicated. And, at face value, you look at it and go, okay, it's just, opportunities to run some runbooks and PowerShell or Python code. No, it actually goes way deeper than that. We've got a lot of different stuff we can pull apart here. So it should be some fun stuff to talk about. So I got a nice intro from David here, but kind of quick background on myself here. Karl Fosaaen. I'm a senior director at NetSpy. I've been a pen tester for about 14 years now, doing a wide variety of different testing, tests over those years here, but primarily been a pen tester for those years here. More recently been a cloud enthusiast. Been doing a lot of work in the Azure space, but at NetSpy, I lead up our cloud pen testing practice where we focus on Azure, AWS, GCP, and pretty much any cloud provider that seems to pop up nowadays, as everybody seems to have a cloud. So, outside of being a cloud enthusiast, in my spare time, I do like to fly airplanes. If anybody ever wants to talk general aviation stuff, feel free to ping me. You can find me on Twitter at @kfosaaen, the NetSpy blog. We now have a technical blog link, which is a little bit different, but blog.netspy.com will get you there. And then the NetSpy GitHub is actually where I put out all of the microburst code. And David gave me all the credit there for the microburst stuff. We do have a number of folks who have contributed to it, several folks on the NetSpy team and a couple of outside contributors as well, who have been super helpful in updating all of that code and contributing. So I really appreciate that. And last thing, David already covered this, but co-author with David on penetration testing for ethical hackers. We had a ton of fun writing this and super happy that this is out in the world. My only regret is, writing things about the cloud. It seems to change almost immediately. So we did have a couple of things that were almost immediately no longer vulnerabilities or changed within the first few months that the book's been out. But overall, really happy with how everything turned out. So what are automation accounts? So seeing as this is an Azure Security Meetup, I hope that folks have some level of familiarity with automation accounts, but we will kind of treat this as an intro so that everybody gets on the same level playing field for background knowledge on automation accounts. So automation accounts are a service for automating actions within Azure subscriptions. Now, these actions could be anything, anything that you want to run code within Azure within a container to automate activities within your Azure subscription or Azure tenant. That's something that you could do within automation accounts. For those that may be a little bit more familiar with other cloud platforms, I'd say that the closest parallel that we could see here is maybe AWS Lambda, where you've got code that you can run within a container within the cloud environment that you can feed credentials to, that you could just automate actions that you need to do. Additionally, you can take in webhooks and other things with automation accounts similar to what you would do with Lambda or other kind of code platforms that you're running the code in the actual cloud provider. So primary things I see automation accounts being used for: resource management, updating virtual machines, applying configurations to specific machines, updating specific resources within an overall tenant. So making sure that specific configurations are applied or code bases are updated, or just changing little configuration things as needed. Uh, there's a number of other kind of administrative type tasks that end up being put into automation account runbooks, but in general, that's kind of what I see them being used for. That being said, I do see them in almost every Azure subscription that I run into, either active use within the subscription or one of the Azure developers, admins, engineers, whatever you want to call them, kind of playing around with automation accounts to see what they can do. That's what makes them a great target for a pen test. Is we will frequently see an administrator that spins up an automation account runbook to, say, run a command on a virtual machine. Well, there are going to be credentials or some type of credential that allow that automation account runbook to run a command on a virtual machine. We could potentially pull those out and use those to access the virtual machine ourselves. There's all sorts of different options for credential access, or privilege escalation, and lateral movement. We'll talk about different options for that during the presentation here, but they make a great target for pen testing. So talked a little bit already about the fact that you're running code within the automation account, but within the automation account, you have runbooks, and these runbooks is where you store the code. So this can either be Python or PowerShell. I primarily see PowerShell. You can also have graphical PowerShell as well. It's more like a module plug and play, almost kind of like a logic app, kind of plugging things together. But typically we just see just pure PowerShell. And with that, you can have custom modules and packages. We won't go that far into it, but you can also upload additional modules to use within the PowerShell code, much like you use a module on your local machine or Windows system or Linux machine to run a PowerShell module. You can run those in automation accounts as well, which gives you some extensibility and interesting things you can do in automation accounts. The code that is in the runbooks is actually available to reader permissions. So if we look at the screen here, that view button right here is available to anyone with reader level permissions on the automation account. And depending on what your scope is for the reader, typically subscription is where that scope's being applied. They can read all of the automation account runbook sources, which we can see on the right side here. With the view published source, here we see password 1 is equal to secret password. We frequently find hard-coded credentials in the runbook code. Part of our kind of standard process for reviewing automation accounts is to go through each of the runbooks to see if there's any clear text credentials just hard-coded in the source itself. It's an easy kind of hack to just get credentials into a runbook. We'll talk about the other ways that we can get credentials in just a second. Last thing I wanted to note on here, with kind of reader level access, I've only seen one instance of it that was kind of an interesting thing, but if you have access to a webhook to initiate the running of a runbook, if that webhook has any parameters, those parameters might be injectable. I did see a situation where you could potentially do command injection injected through a webhook. Kind of a small little fun thing, but something to look out for as you're taking a look at how the automation account runbooks are being run as to how the parameters are being processed within the runbook code itself. So actually executing the runbooks, you've got multiple different options, and these kind of vary in the stealth of the execution. We've got one other method that we're going to talk about later, but we'll leave that to that slide. But these are kind of the primary ones. Running as a regular job in the automation account. This is very visible in the logs. As David mentioned with Microburst, we have a tool called Get AZ Passwords that actually automates a lot of these credential extractions that we'll talk about. And that runs all of the actual credential extraction as a regular job. This is very visible. This is intentional. We do have an option to run everything in a test pane, which we'll explain in a second. But running as a job is just kind of your standard way to run things. Scheduling a job to run or triggering with a webhook is an alternative way to do running a job. Shows up in the logs the exact same way that a job was run. And from a schedule perspective or a triggering with a webhook perspective, those are both good options for persistence. If you have a malicious runbook that you want to leave in an automation account to keep persistence in that automation account, either scheduling that job to execute the commands that you want to execute, say after you've been kicked out of the environment, or having a webhook that you can call to run that automation runbook after you've been removed from the environment, can actually be really handy for reestablishing access into an Azure subscription. The last item on here is running in the test pane, which we see on the bottom right here. So when you go to edit the actual runbook code, you can click on something that says test pane, and you can actually run a test version of the runbook in the test pane. And that doesn't show up as much in the logs. It doesn't show up as a specific job that's being run. I believe that it just shows up as a save of the runbook was completed. And I think that a publish of it shows up. I'd have to double check exactly what's in the logs, but it is a more stealthy way to run. So as I mentioned, Get AZ Passwords actually has an option to use the test pane versus running as a job. So a little bit more stealthy on that. But these are kind of the four primary ways that we would execute any of our runbook code options. So within the runbooks themselves, like I said, it's PowerShell or Python, and you may have repeated variables that you want to share across multiple different runbooks within a single automation account. So one of the ways that you can share those variables is through the variables component of the automation account. And we often find credentials or keys just living in those variables. So domain admin password equals password123. And that can be referenced by any of the runbooks that are in the automation account. So in terms of extracting these out of the actual automation accounts themselves, if we were to put together a runbook here that does get automation variable and name the test variable, the nice thing about the editor within the Azure portal is you can actually just directly reference and right click on the variable and say add to canvas, and that just puts it directly in here. It just does the get automation variable with the variable name. And then we can just write that out to a screen. So we can see that the value here is test variable value for the test variable. So like I said, we do frequently find credentials and or keys being stored within those variables themselves. Definitely something to look out for, but more interesting is the actual credentials that get stored here. So the credentials for the platform credential options here is an automation account level credential that's stored within the automation account. So typically username and password combination here, and we see all sorts of different credentials here, be it Azure Active Directory, external tenants, domain or local credentials for potentially talking to a virtual machine. There are all sorts of different interesting credentials that end up in these stored credentials. Where I feel like this is kind of a problem with automation accounts is that although it's called a credential and it looks secure, if we look in the portal here, everything's asterisked out, we're able to very easily extract that from an automation account runbook, which, yes, that's intentional, but 3 lines of code versus 2 lines of code to get both a username and a password really isn't that much more difficult than the 2 lines of code that we wrote for the test variable. So, there are benefits in terms of how these credentials being encrypted on the back end and how it looks a little bit more secure, but at the end of the day, credentials being stored in automation accounts are really not that much different than automation account variables. There's really no additional restrictions that I'm aware of around those credentials in terms of who can access them. Anyone that can write a runbook in that automation account can extract them with the lines that we talked about here. And like I said, it is a credential. It's stored as a PowerShell credential, so it is stored in a protected format in the backend. But if we're able to just pull those out directly with the runbook, we can get the username and password. Again, this is all automated with Get AZ Passwords, so something that ends up in the output of the Get AZ Password stuff. So just checking the chat here to see if there's got any questions. So as an alternative to having credentials either stored in the variables or credentials being stored in the credentials format, there is the run as account. Now, this is the older method for authenticating in Azure Active Directory within automation accounts. So run as accounts are a service principal that's created with a certificate as its credential and then tied directly to the automation account. Now, typically when these were created, back when run as was the primary method for authenticating with the automation account, this was granted the contributor role on the subscription by default. Now, in a lot of environments I run into, there are legacy run as accounts that are just floating around. So it's basically a contributor attached to the automation account, which then just exists. And some of those have credentials that will be expiring soon. Some of them have already expired, so you can't use them. However, we can extract those certificates tied to the app registrations directly from the automation account runbooks. So like I said, this is something that is kind of an older method and is being phased out. We'll talk about managed identities in a minute here. But as an attacker going through an automation account, we can use the code that I have here with the view published source to go ahead and pull the run as certificate that's attached to the automation account. You can have multiple different connections that are available as run as. It doesn't just have to be the single run as. There's other different things that we can pull out with the connections as well. But we can basically use all of this to cast out the PFX file for the run as certificate directly from the Git automation certificate here. So super handy for persistence as an attacker. If we're able to get this PFX file and the service principal credentials here, we can get access to the automation account run as account whenever we need it. I haven't seen a whole lot of application of it, but now you do have conditional access available for service principals. But for the most part, I haven't seen that implemented. But from persistence perspective, it's going to look less suspicious as a service principal logging in as a contributor to that subscription versus a direct Azure Active Directory user. So long way of saying these are really handy for persistence. So dump those credentials if you want to persist access to that automation account or to that subscription as a contributor. So kind of an extension of that, David mentioned this as we got started here, but we did have a vulnerability that we reported back to Microsoft in, I want to say late September, early October. But we called it cred manifest. In the manifest for the app registration itself. So if we look at the screenshot here, this is in the Azure Active Directory menu, and then you go to the specific service principal, and then go down to the manifest that's attached to that user. What should have been happening is in these key credentials, the value here should have been the public certificate so that you could verify the private versus the public, and everything's good to go within the manifest there. What was happening was on backend processes for automation accounts, Azure Migrate, and Azure Site Recovery, the PFX file was actually being written to the value in this key credentials parameter here, or JSON data here. And what we were able to do as an Azure Active Directory user is take a look at all of the app registrations, pull the manifest for them, and then get the key credentials out of each of them, grab all of that certificate data, base 64 it down to a certificate file, and then we have the actual PFX file for the app registration. This is pretty bad. Any Azure Active Directory user in most environments has the rights to read those app registrations. So if we go back to those run as accounts that we just talked about a few slides ago, the automation accounts themselves, or I guess the previous slide, the automation accounts are typically a contributor on most subscriptions just by the creation of the run as account. So what we found is that run as accounts created between a certain time period were storing those PFX files in the manifest, and that gave pretty much any Azure Active Directory user with the ability to read those registration manifests, the ability to become contributor on those subscriptions. So pretty much any subscription that had an automation account in it with a run as, you had contributor there. So very impactful in an actual Azure Active Directory tenant. We worked with Microsoft to get that disclosed, got a CVE applied for it, but that got fixed I want to say mid-November. Had a bunch of stuff happening in November, including the book coming out and having this cred manifest vulnerability published as well. So kind of an interesting extension of the run as. So as an alternative and something that Microsoft's really been pushing for, kind of post this cred manifest, and it's kind of the direction they've been going anyways, since the run as accounts are really more of a deprecated method here, is using managed identities for the automation accounts themselves. So much like other services that can use managed identities, you can either use a system assigned, which is tied directly to the resource itself. So in this case, an automation account, or a user assigned managed identity. And these managed identities are a security principle within the Azure Active Directory tenant, and they can be assigned specific roles within the Azure AD or subscriptions themselves. And in this case, I think this is a better move for Microsoft to switch over to the managed identities. You have much more granular control over which permissions you're going to apply directly out of the box. It doesn't automatically apply contributor to anybody. You actually have to assign the role permissions to the managed identity as you set that up for the automation account. I think this is better. However, I do think that you're going to get some cases where the Azure engineer or admin is a little overzealous with the permissions, and you get somebody with owner, or you get other higher privileged roles being applied through the Azure role permissions that weren't necessarily intentional. The other item here is user assigned managed identities. We do see those being shared across multiple different services. So a virtual machine and an automation account have the same user assigned managed identity. And those can be over permissioned as well and potentially allow for pivoting between different things. So if we're able to get a token for the management interfaces out of automation accounts, that may allow us to pivot over to app services or pivot over to virtual machines, anything like that. So in order to get a token for the managed identity, we use the managed service identity endpoint, which is available within the automation account runbook. Now, every service seems to have its own different endpoint for generating tokens for managed identities. I put a blog out on the NetSpy blog a little while ago about generating those bearer tokens, but it seems like every different service has a different way to call a metadata service or an MSI endpoint to get those tokens, but they are super helpful once you have access. So in our case, if we've got access to an automation account and we want to get access to the automation account managed identity that's attached, we can just make a request out to the MSI endpoint. It does require a couple of different headers on it in order to properly complete the request. We'll talk about that more specifically in a second. We can write that token out to the output if we've got direct access, or potentially if you're in a persistent situation where you want to, say, send yourself a managed identity token, you could exfiltrate that via post request, write it out to a storage account. There's a number of different things that we could do there to potentially exfiltrate the token there. And just taking a look at the chat here. All right, thanks for the kind of capturing those thoughts there in the chat. So with the managed identities, this happened, I want to say November-ish timeframe when this was initially discovered, but Orca Security came up with the autowarp vulnerability, which used those MSI endpoints and identified the high number ports that were available within the container space for the containers that run the automation accounts. So to step way back to runbook execution, everything, all of those runbooks are actually executed within containers in the Azure infrastructure. And what Orca found was that when they went to request the managed identity tokens, that went to a specific internal port on those containers, and they were semi-sequential with the other containers in that same space. So they were able to enumerate these high number ports that were available to their container and generate tokens for managed identities of other tenants. So massive cross-tenant vulnerability here. Definitely recommend go out and read their blog. Since that, I've been poking with every single service that I can find on Azure to see which ones have managed identities attached to them and which ones run in containers. I haven't found anything good yet, but I believe Microsoft went through all of those others to kind of shore that up. But definitely a really interesting vulnerability here, and massive impact there. Question in the chat here: do you recommend any books to understand attack surfaces better about Azure Cloud Environment? Conveniently, David and I co-authored a book about that. But from a book perspective, there's Matt Burrows' book about attacking Azure applications. We can drop links for that as well. And honestly, any of the Azure security related books, David's other book with Pact Publishing, really just understanding the security implications within Azure itself gives you a better idea of what those attack surfaces are, because you learn more about the defenses that are there, and you understand kind of what those attack surfaces are based off of those defenses. So going kind of beyond the identity stuff here and back more into the components of how we can utilize automation accounts in subscriptions is desired state configuration. So these are typically used for managing systems configurations for virtual machines or on-premise Azure Arc systems, where you want to have a specific configuration applied. Now, DSC is part of the Windows underlying operating system. We could probably spend a whole presentation talking about that. There's some really interesting stuff going on with desired state configurations. But in general, you have policy files that you set up. They're basically PowerShell files that can be used to run specific processes on the endpoints or nodes in the DSC environment. So we see it for things like domain joining, running specific processes, ensuring that, say, an IAS server is continually running and updated, is running within a specific path, so it's serving a specific website. It has that configuration that it wants. We can use this for command execution and or persistence. I've linked a blog here for the Nets by Technical blog using desired state configurations for persistence within Azure. Jake Carnes on our team has done a great job diving into DSC and all the fun things you can do with that. But really, that's using the extension for DSC to get command execution on Azure virtual machines. So super handy. It's a nice alternative way to get command execution, and something to kind of keep in mind. I don't know if anybody else goes through the built-in Azure roles and reviews them regularly, but taking a look for potential pivoting and privilege escalation options, that's something to keep in mind. Additionally, I did mention the Azure Arc systems, which are enrolled on-premise systems that may be getting DSC configurations. If you can push a malicious configuration down to an on-premise system, you might be able to get to the on-prem environment and start pivoting within that standard kind of on-prem network. Additionally, this is something that I wanted to kind of sneak in here. With the configurations themselves, they're PowerShell files. They're seen in the portal here under configurations. You have to compile them first before you can actually apply them to the nodes. So you'll see compiled configurations here in the menu as well. But that compilation action for the configurations actually happens in your Azure automation account container. So the same container that runs your Runbooks also runs the compilation for these configurations. They get compiled to MOF files that then get pushed down with the DSC. But if you want kind of a sneaky way to run automation account code that looks more like, oh, it's a DSC compilation activity and not necessarily a runbook run, this is kind of a sneaky way that you can work around that and put that runbook code in the actual configurations. So kind of an alternative method there. So next thing is hybrid workers. So these are all just kind of different options that all fall under the umbrella of automation accounts. I did just put a blog out for stuff related to hybrid workers, which we'll talk about on this slide. We also have another slide that I wanted to talk about today, but we don't yet have full approval for disclosure on this related to hybrid workers. I can give kind of hand wavy explanation of what's going on there, but we'll talk about it at the end of this. But there's a pending NetSpy blog that'll be out pretty soon here. So for hybrid workers, they are typically, we'll just consider them Azure virtual machines in this case. You can have the Azure Arc systems as well as nodes or workers within the hybrid worker group. But hybrid workers are an alternative option to the containers that are run on Azure. So if we look at our little test pane window here, you can say either run on Azure or run on hybrid worker, and you choose your hybrid worker group. So when it's run on Azure, this execution happens in that Azure container. If we go hybrid worker, that sends that job out to an Azure virtual machine and says, hey, go ahead and run this PowerShell code for me. Give me the results back here. It uses some kind of undocumented backend APIs to execute all of this stuff and get jobs and all of those kind of things. Again, this could probably be its own presentation about hybrid workers, but it is a very interesting area within Azure at the moment. So the reason why we do this is because if you want to get out of the CPU, RAM, disk space capacity issues that you may have with running in the Azure container itself, you can ship that off to a very well-provisioned Azure virtual machine to run to your heart's content. There are time restrictions and other things that kind of happen with automation account runbooks that kind of throttle down all of the things that you might want to do. So you may want to ship that out to a virtual machine. As part of this, in order to get access to a run as certificate, let's say that the automation code needs to do something as a run as account, you actually have to run some automation account runbooks beforehand to install. You basically use the same code that we showed earlier for exporting the PFX file, and then you push that down onto the actual virtual machine itself. Microsoft provides a runbook that you can run to push those run as certificates down onto the hybrid workers, which kind of interesting. But the end result of that is that run as certificate ends up on the virtual machine that you actually want to use as a hybrid worker. So we as an attacker, if we have local admin on that virtual machine, we can just go ahead and tell the virtual machine to extract out that certificate for us. It's not marked as non-exportable on the machine. And with local admin rights, we're able to export that certificate. If we're able to take that thumbprint for that certificate and match it up against the automation accounts service principal for the run as, we can query Active Directory for that and then get the run as credentials right there. So certificate, we get the app name, get the tenant, all good to go, and then directly extract that. We have a function in Microburst now that does that. It just scans all of the virtual machines for the hybrid worker extension. And if we know that it's there, we can try to pull any of the private certificates off the system at that point to hopefully authenticate to the tenant. So that's super handy because it just outputs a PS1 file that you can use to automatically connect to the Azure tenant at that point. But there's multiple different roles that actually execute commands as local system on virtual machines. Now, I won't go through each of these, but it is kind of a mix of the run command privilege on the virtual machines, or either desired state or the extensions option. So running custom extensions on the virtual machines themselves. Either way, we're running code as local system on the virtual machines themselves, and we can extract those run as certificates that we as attackers can then use to escalate our privileges. So it's a minor escalation. I went back and forth with MSRC on this. I think it is a true privilege escalation, because if you're able to go from a VM contributor, and there is a misconfiguration in the sense that you have to have an environment configured for this, but if that run as by default is contributor, and you as a virtual machine contributor on, say, a single virtual machine, were able to extract that run as, you'd be able to escalate up to the contributor of the subscription. So it's kind of hand wavy. There are options potentially to escalate to full contributor if you want. Just keep that in mind with some of these. So the last role that we noted here for Azure RBAC for having the ability to run those commands is Log Analytics Contributor. That makes the list here as kind of an honorable mention for a PrivEsc option. This has since been remediated, 7-8 months ago, something like that. But August of last year, they removed the automation account permissions for the Log Analytics Contributor role. But since this does apply to automation accounts, wanted to mention it here. The more recent Azure RBAC policy that was applied for the log analytics contributor allowed the star permissions on automation accounts. So with that, as a log analytics contributor, we could write our own runbooks and export the run as certificate from the automation account, which by default was being set up as a contributor on the subscription, and we could pivot from log analytics contributor up to full contributor, the subscription. So the case I was making for these other Azure RBAC roles here on the previous slide, tried to make the same case to Microsoft in terms of that kind of escalation. They have updated some documentation around those specific roles and hybrid workers, so I'm going to call that a positive. So this has since been fixed. The automation account star is no longer there, but if you have log analytics contributor, which I do see being pretty regularly used in Azure tenants, you do still have the option to run extensions on virtual machines, which also counts as the ability to run commands as system on the virtual machines. We can export the run as, escalate to contributor, and escalate our privileges. So kind of in conclusion here, question here, can you share the presentation later? Yep, I'm going to PDF these slides and I will have David share those out with the meetup group after this. But kind of conclusions here, in general, automation accounts are really useful. We've seen them being used to do really interesting things in client environments. I've been in probably hundreds of different subscriptions over the last 5 years here, and I've seen very, very creative things being done with automation accounts. However, they can be really dangerous. They're often misconfigured. They can expose credentials, allow for privilege escalation depending on what roles or access you have in the subscription itself. I will give Microsoft credit, especially with the move away from run as accounts towards the managed identities. They're definitely making security improvements and really taking that serious. I think there's lots of potential impact, especially with the autowarp vulnerability that just came out here. So there is potential for cross-tenant issues there as well, similar to other cross-tenant issues we've seen in the last couple of years here. But Microsoft is really trying to make improvements here. So I do encourage people to use automation accounts. Just make sure that they're really well secured and properly configured. And yeah. And last item here, potentially a target during an Azure pen test. Absolutely. If you are pen testing an Azure environment, do yourself a favor, take a look at the automation accounts. I can almost guarantee there's going to be something there, be it a stored credential, be it an over permission service principal, managed identity, run as account, anything like that. Definitely lots of potential for escalation there. So seeing as this is kind of my subspecialty within Azure resource or research itself, we've got a number of different automation account related blogs up on the NetSpy blog. We've got those all linked here. You can find more of our work here at the NetSpy technical blog. Likewise with Microburst, all of the tools that kind of relate to the things that we talked about here. And I frequently tweet about stuff related to Azure and automation accounts and all that kind of stuff. So feel free to follow at Karl Fosaaen on Twitter. So I'll leave this up here, but does anybody have any additional questions?
Oh, that was really, really good. That was really, really good. So I'm looking at the chat window.
Thanks.
I can't see. Oh, no, that was awesome. Thanks very much again for that, Karl. It's just so amazing. Like, I mean, we talk about platforms like Azure and with over 180 services and just the potential for exploiting the platform and exploiting services on the platform, just a single service, and you have all these potential options, for persistence, for privilege escalation, and all of that stuff. So if someone was considering to use like an automation account, what would you recommend would be like the top things that you say, check this immediately? This, you have to get this one done to prevent you being a victim of like a pen tester or even what was like someone that has malicious intent.
Yeah, so I think first things first, take a look at what that attack surface area is in the automation account. So see if you have any credentials stored, be it clear text in the runbook
Mm,
code or in the variables, the credentials, anything like that. Definitely take a look at what that surface area is, particularly with run as accounts or managed identities, as well as to what RBAC roles could be assumed by anybody with access to those identities or credentials. And then kind of from there, taking a look at any execution history within the jobs themselves or with webhooks being called, anything like that. We do occasionally see automation account webhooks being published out through public GitHub repos or being exposed somewhere that they didn't intend to be exposed through. So once you have access to the webhook credentials, you can potentially run the automation account and potentially run that with different parameters that get injected in, anything like that.
mm,
I think that's less likely. I don't think that's actively being exploited by anybody. But
mm.
if somebody were persisting, using the webhooks is definitely a good way.
Yeah, awesome. Now that's amazing. Like you did mention something that's so powerful. Like you said something about having a look at sort of like the whether you have like variables or whether you have like credentials that have been configured as variables or as credentials in automation account. So it's one of those things that I have struggled with in the past in terms of getting like an effective way to do that at scale, right? To be able to just have a look at all these different services where there's potential to have all of this and see is anybody having any sensitive credential anymore. Do you have like any suggestions or any thoughts on having a
Yeah.
look at some of those? Yeah.
So conveniently, we have a script within the microburst repository. It's called get
Nice.
az domain info, and that
Mm,
will dump out all of the runbook code along with the variables. I
mm,
believe the variables directly from the automation account information. In order to fully extract some of the other stuff, you actually have to run runbooks on that. We don't do that with the get az domain info,
mm.
but it does pull out some of that information directly in the output for get az domain info.
Nice, nice. And I can see Ibrahima has something here, which I'm not sure, but let's go on to that. So Ibrahima is wondering why some of these vulnerabilities are not captured by Defender for Cloud at least as a risk. So essentially what you're asking Ibrahima is, hold on, like why is Defender for Cloud not actually just stopping all of these issues versus just as a security product that's doing some auditing at the end. So, any thoughts on that? Like, how the cloud providers are they really like doing enough in terms of really auditing to make sure that they are doing things securely?
I think a lot of this stuff is there, and I have seen environments where Sentinel's in use, and Sentinel's great. You can write really good queries to pull out potential attacks, and people that have that set up works really nicely. But I've also seen it where they're relying on Azure Security Center and not really getting a whole lot of value out of that. They might catch a couple of things here and there. A lot of it does come back to the shared responsibility model, where it is partly your responsibility to not put credentials into the runbooks themselves. Microsoft would say that the credential in the automation accounts is something you put there, and you are supposed to be putting proper RBAC protections around the automation account itself. So don't give everybody blanket contributor to everything in the Azure subscription, limit access to the automation accounts, things like that. Again, it comes back to the shared responsibility model. So I think there are definitely some things that could be captured within Defender for Cloud or Azure Security Center, all of those available tools. I think it just kind of comes up to priority.
Yeah, true. And the scale is also massive. It's a tough thing to sort of like go like what you just brought up. You brought up something at the end where you said log analytics, log analytics contributor permission, has permission to do all kinds of stuff. One of the things that's listed there that was a very interesting when I was looking at that was permission to list all the keys of a storage account. You're like, oh, I just want you to be able to contribute to to be a contributor for log analytics from giving you access to all the data, all the storage accounts to this subscription. And having a look at some of those sort of like permissions. Yeah. So Morato has a question here. It says, do you suggest every feature in Azure Cloud to be threat modeled using the same
That would be good. From a time and effort perspective and just being agile, it's kind of hard to threat model all of those things out. Building with least permissions up front and really limiting access and removing users as much as possible, and moving towards more of a service principal type model where you're really restricting access. I think that would help because it helps simplify some of those threat models. If you say, hey, we're going to use automation accounts, it's only exposed to this specific service principal, or this managed identity is the only thing that has access in there, and being able to model out kind of what points of access those identities have outside of that specific service, I think that's good.
Mm-hmm.
But in practicality, you get into an environment and people are actively building things. Everybody has contributor across the entire subscription, and everybody has access to everything, and the water gets really muddy, and it's really hard to see where you could actually model proper authorization across everything, because you get so much crosstalk between everything that's there. Definitely good to do threat modeling in your environments, but threat modeling every different Azure service out there before you actually make use of it, that's going to be pretty tough.
Yeah, awesome. Man, Karl, it's been a pleasure. Really, really appreciate you taking the time out to share this very, very useful information that you shared. So it definitely gives me a pause to make sure that I assess how things are being used in the environment that I'm responsible for. So thanks very much for taking the time to share that. And so we're going to keep an eye out for the blog that you mentioned. So Karl said we should be looking forward to a blog on NestBy blog. So we'll be looking for that. So, and again, so thanks very much for doing this, Karl. It's been a pleasure and very, very insightful.
Yeah, thank you. And I can give you kind of the high level. We were able to escalate from a reader on the subscription through the automation account hybrid workers all the way up to the run as credential. So we were able to get all the way to the run as credential from a reader on the subscription. So that's about as much as I could probably talk about. I think the blog's going to come out next week, but we don't want to jump the gun on it. The stuff has been remediated. There was one more question about, or a couple more here about unsecured defaults that you need to concentrate on. There are a bunch of unsecured defaults that are kind of out there. We do try to identify some of those things in Microburst with some of the tools that we have there. But yeah, the unsecured defaults is probably a whole nother presentation out there. And then for the Defender for Cloud, I would be really nice if they added in a whole bunch of other kind of default detections for things like run as accounts are in use. It is something that we audit for when we do cloud pen tests, and password storage and runbooks. That would be really nice to add, but not quite there yet. So yeah, thank you for having me on today.
No, it's been a pleasure. Thanks very much, Karl. So thanks very much, ladies and gentlemen, for joining us today. So again, make sure that you follow our Meetup page so that you can get announcements on upcoming sessions that we're putting together. So this is where we're going to stop for today. Thanks again, Karl. Do have a lovely day, evening, afternoon, everyone, and see you next time. Bye, everyone.
Thank you. Bye.
Yeah, thanks. Bye.